All right. Welcome to class, guys, and I welcome you officially to today's class. And today we'll be looking at light waves, right? And we're going to be looking at the basic introduction to your light waves, right? And in the last class, we established that light is an electromagnetic wave, right? Light is electromagnetic, right? In the sense that it travels through a vacuum. It doesn't require a material medium for the transportation, right? So it travels through a medium, right? Then we said, instead of example now, sound and water wave travels through a medium, right? But then your light, example, light wave, your X-rays and the rest of them, radio waves, they travel through a vacuum, and that is why they are regarded as what, um electromagnetic waves, right? And now one key feature about your light wave is that it travels in a straight line. So that's why we wrote down here that rectilinear propagation of light is simply the principle that light travels in a straight line, right? As long as the medium in a homogeneous medium, that means same material throughout, right? So now, as long as there's no obstruction, right, the light will keep traveling in a straight line. That is what we mean by what? There is a linear propagation of what? Light. Unless there is an obstacle, right? Unless the material through which it's trying to pass through is not uniform. That is when there will be a change in direction. Remember that that will now bring about what we call your refraction. It brings about refraction, brings about reflection, bouncing back. When there's an obstruction, it bounces back, isn't it? But light will continue to travel on a straight line unless it encounters an obstacle, right? So, what are the conditions for rectilinear propagation of light? Number one is that the medium is uniform, right? The medium should be what? Uniform. Number two, there is no obstacle. Number three, the place the material is traveling through should be transparent, right? You know what a transparent material is? That a material is transparent. That means you can see through it, right? Because you can see through, then light can actually keep traveling in a straight line. So these are the conditions upon which, right, light remains rectilinear. It keeps moving through a straight line. So these are the key conditions. It's going to be a very fast class, very quick lesson, just to give us an overview of what we need to know. Then we'll go straight to self-pass questions. So Paul, as usual, you can check questions on rectilinear so that we can get that done. I was thinking I'm going to do things on reflection and refraction today as well, right? Reflection in particular, total internal reflection, and the rest of them. There's a reflection of light from plane surfaces, but I couldn't get those things down because I like to read through, then bring out the key points for you. So you just, because of the exam, I want to just get the key points you need to know, and you go straight to the point, just like what we did in equation of motion, getting the key formulas you need that works across board. So Paul, you can do that for us. So now these are the conditions for your lights to remain what? Rectilinear. Please take note of these conditions. It's as important as anything that you can imagine. All right. So the next thing I spoke about is what are those things, what are those experiments, what are those things that actually say that indeed light remain travels in a straight line? What are those phenomena? What are those things we're going to look at? And we say that yes, indeed, the light travels in a straight line, unless there's an obstruction, unless the material is not transparent. So one of them is the formation of shadow. You know what shadow is, right? So now, for example, I'm an opaque object. What is an opaque object? An opaque object is something that doesn't allow light to pass through. So therefore, when you shine light on me, because it can't pass through, it's going to cast a shadow at my back. Are you seeing it now? That is what we mean by shadow. Example now, when you bring light and pass through, just shine light here, automatically because it cannot pass through, we're going to have shadow, right? A shadow will be formed at the back. So formation of shadow is a very key phenomenon that talks about the rectilinear propagation of light, right? So, but they are different. You know how physics can be. It is when you start studying physics that you start seeing that there are different kind of shadow. The physics can be funny. They now want to give you context to penumbra, the umbra, what happens in penumbra, and the rest of them under this rectilinear propagation of light. So I want you to pay key attention to those extra details as it stands now. So now shadow is formed when object blocks the light. So when an object blocks the light, automatically we know that shadow will be formed, right? So back then, um, don't laugh. I'm just trying to give an example. This what we normally do back then as kids, everybody, there's this wall, a white wall, then all of us will stand just this way. Everybody's just standing, right? And then what we'll normally do is that towards evening time or at night, basically. So when you stand, you are facing like you are facing this way now, like you are facing this way. Now your head will now be close to the wall, right? Your head will now be close to the wall. So now when the light is shining on you, we are seeing the back of your head on the wall. And then people like me will suffer it most, because I have, if you check, you see that I have, what do you guys, I think it was trending online the other day. It was trending online. I think, what do you guys call it? Huh? What do you guys call that thing again? There's a name they gave it, right? So we'll start seeing the shape of the back of your head back then, and people will start laughing because the shadow gives exactly how it is. And you know how shadow can be. It can even make it bigger, right? It can make it bigger. So now, these are some of the things we did back then without really understanding that we are playing around with a physics concept, right? Oh, just what do we call it? I think OP in Igbo language we call it OP. I don't know, but there's a name trending online now that they gave it. Yeah, OP in Igbo language. But there's a name they gave it of recent on social media. I'm seeing currently. I think people like Nikki Gold we know, or Titi will know. What's the name they gave it of recent? Lillian. I think I saw that online. Meanwhile, Nikki Gold is no longer in class. Please, someone should reach out to her to tell her we started. I know she was there in the beginning when I'm yet to set up. So tell her we started, so in case she doesn't know. All right, so that's for that. Now, because we are blocking that light, shadow is formed. So, but there are different kind of shadow, right? We have the umbra, a part of shadow actually. We have the umbra, we have the penumbra. So the umbra is that part that light doesn't get to that place at all. That is full shadow. Are you seeing it now? So that's the darkest part of the shadow. Light doesn't get across to that point at all, right? So the umbra is that portion of the shadow that light doesn't watch. Light doesn't get to that very portion. Are you seeing it now? So it is behind an obstacle. Is that portion behind an obstacle that light doesn't get through? That's the darkest part. That place you have your full shadow. They will have the penumbra, which is your, I might not be pronouncing very well, but just get to know the spelling there. I'm teaching you physics, not English. That's your business. Penumbra or umbra. Then we have the partial shadow. So light doesn't get to that. There's a portion of it, like light gets a portion of it. Is always behind an obstacle because when you have an obstacle, that is when shadow will be formed. So behind that very object, you have that the light gets to that part, right? Partially. So, but that portion without light is what we regard as the what? As the umbra. Then the other side is penumbra. Now, there are different kinds of shadow. We have the black shadow and the gray shadow. If you are used to your past questions, you must have seen questions along this part of this black shadow and gray shadow. If you've seen that kind of question, can I see your hands up? If you've seen that kind of question, I need a thumbs up. Good. So now, the umbra, where the umbra intersects the source, we have a black shadow. So when the umbra intercepts the source of light, we'll have a black shadow. Now, when the penumbra intersects the source of light, we'll have a gray shadow. Just a simple term for you to always remember at every point in time under the rectilinear propagation of light. If we are still together, can you give me a thumbs up, everyone? A thumbs up if you are still following to this point. All right, beautiful. Susan, how are you doing?
Fine, sir.
All right, great. Nice to hear from you. All right. So now let's proceed. We'll have the black shadow and we'll have the gray shadow. That said, let's now look at a very important thing, which is your pinhole camera, right? Pinhole camera. Pinhole camera is also a particular object, or I call it an object or a mechanism that actually explains the rectilinear propagation of light. I wish there is time, I would have actually watched a video on that pinhole camera so you see what happens right there and how the entire concept or the principle or the mechanism behind the pinhole camera, right? But then I think they will not have time to go through that now. But please, on your own, if you just go and watch the pinhole camera. But for your exam, I will just give you the key things you need to know. But someone like me, I don't prepare for exam that way. I want to know the behind the scenes. So you can just watch pinhole camera experiments. Once you search pinhole camera experiment, you're going to see what the experiment is all about, right? But let me just give you the key concepts, the key things you need to know is that in that very pinhole camera, we don't use a lens. That was the old form of the camera before we started developing the new ones, right? It's just makes of a very small hole, right? And an object is placed, and the kind of image that is formed. That's what Jam wants to know. It forms a real image, right? And the image is also inverted. Now, but there's something key they want to know. They will tell you what happens in a pinhole camera when the hole is larger. When the hole is larger, the image becomes brighter. I think well, let's watch that video. What do you guys think? Let's do that, guys. What do we think? What do we think? Yeah, Paul is giving me a thumbs up. Titi, are you here? Justice says a thumbs up. Okay. Susan Grace Abraham. Susan, I like your name. You are combining a lot of things. You are Grace. You are Abraham. You are still Susan. That's interesting.
It's my dad that gave me the name, so what would I do?
Oh yeah. It's a good name actually. It's a good name.
Thank you, sir.
You're welcome. All right. So let's watch that very video. Uh, just like I'll give my own daughter now, I'm pitying the young lady when I'll give birth to them. There will be a Yoruba name, there will be a Igbo name at the same time. Then I will look for Hausa and join. So they will have three names: Igbo, Hausa, Yoruba, and English. Kaja. Kaja, your name now sounds like a motorcycle name. Kaja. Do you know this Trojan? So pinhole camera, I hope my this thing will allow me. The pinhole camera experiments. So let's watch that video. Can you hear me, please? A thumbs up if you can still hear me. So why are you guys laughing? I left the call. What happened? Like I minimized. What happened? People were laughing. Hope all is well. Is it because of the kaja? A thumbs up if you can see the screen. Thumbs up if you can see the screen. Hello, can you see it? Hello? Okay, 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 okay.
The video is cracking and no sound.
Are you serious? How about now? Is there sound now? That's like it's like something I can do now. So I don't really depend on it, right? Yeah, I will send the link later so you guys can watch, so you can save time. You can see it's cracking, right? And I know that was why I was skeptical about it. So just on your own, I'm going to send it to the group, right? Just look at that so you understand the concept very well. Just take your time to explore, right? I hope you can still hear me. A thumbs up if you're still with me. All right. So the key things I want you to remember about that pinhole camera is that the camera, inside of the camera is painted black to avoid what we call total internal reflection. Just keep it at that. Later, you're going to see what we mean by total internal reflection. But do you have anybody that have watched the videos on your video lessons on the dashboard on the light wave, where they talk to you about total internal reflection? Anybody that have done reflection of light to a point, reflection and refraction to a point that you know what total internal reflection is? Anybody on this call that knows what total internal reflection is? Any human being? I should start calling names. If I call your name, if you don't know it, say I don't know it. The first person I can see here is Justice. Justice, what is total internal reflection? Confirm you can hear me. Yeah, you talk now. So what is total internal reflection?
I'm not sure, but I think it's the total reflection of light back to the back to the
Hey, because it's total, Abby. Then the total reflection. This guy, funny young man. Meso, over to you. Meso, over to you. If you don't know, save our time.
Total internal reflection occurs when light travels from a dense medium to a less denser medium.
Are you serious? And then what happens when it travels from a less dense medium? What about refraction?
Jesus, sorry.
Go ahead. I'm listening.
I don't know. I've not done refraction.
Okay, you've not done refraction. Okay, it's fine.
I noticed that you sent the video for only refraction, but I did reflection first. But I didn't have more time. I was feeling sleepy, so I postponed that one to next time.
Okay. So, but there's a video on the refraction. Are you there now? Because it is under refraction that you have a total internal reflection. Now you said something less dense to a denser medium, right? But that's not the key point. I don't want to explain. Now, Susan, over to you. What is total internal reflection?
Total internal reflection.
Well, Meso, at some point, Meso, your overview about traveling from a less dense to that's one of the conditions what you just mentioned, one of the conditions. Is that okay? But there's something I was looking for from you. Go ahead, Susan.
Total internal reflection. Dual light hits a boundary between two mediums.
Come again. They are speaking in parables. Is that what happened?
Dual light hits a boundary between two mediums.
When light hits a boundary,
Yes.
like you boundary mean Nigeria and Cameroon, or I don't know. I don't understand. Susan, by boundary you mean Nigeria and Cameroon. Is that the boundary you mean?
No.
Who is the person that ran away from the goal? So I will not ask. Who is the person that just left the goal now? I didn't see the name. Okay, Susan, you've tried. That means you at least know to some point that there is a refraction, right? It hits a boundary. Is that okay? Are you there?
Yes, sir.
Yeah, I've tried. Okay. Now, Titi, over to you. You know I disturb you a lot. I don't know why. Titi, I'm go over to you. This is 3 weeks to your exam, and I'm asking what is total internal reflection. So go ahead, Titi Lola.
Okay, I did not watch the video, but I can give an idea of what I know.
You always speak English. I'm gonna give an idea of what you know.
Okay, so total internal reflection is when light hits a boundary at an angle and then reflects back.
It hits light at an angle and then reflects back.
It
Okay,
hits
interesting.
a boundary at an angle and then reflects back.
It hits an angle. Okay. Okay. Next person. Nikki Gotsiva, over to you.
Sir, let me try now. I don't know,
Run.
but can I say something that is connected to light?
Yeah, go ahead. Okay, something related to light. Okay, that's quite interesting. Now, when you guys go to the exam hall and they say, what are the conditions for total internal reflection? There are two things that you must have mentioned one of them, which is what I want to hear. Some of you are giving me what you probably a boundary hits type. Paul, wait, before Justice, I'm coming. Paul, before you, confidence. Confidence. What is total internal reflection? I know you can, because of the place you are currently, you can't talk, but you can type. Let it not be an excuse. So, Paul, over to you.
So I think total internal reflection is when it's passing from a dense medium to another a less dense medium, and the critical angle is I think equal to or at 90
Come
degrees.
Come again. There's something you said. What happened?
The critical angle. I think it's at 90 degrees or something. I'm not so sure.
Now, you've mentioned something because of what you mentioned critical angle, which means you have an idea. That's where the critical angle is entirely fine. Justice, over to you.
Based on what someone said here, that it reflects, is trying to say when it hits, let me say a wall that the light cannot pass through. Since the light cannot pass through that wall, it then reflects back to
good. In summary, you guys are making a key point, but there are key things. Mr. said something. You're moving from a denser medium to a less dense medium. Now, remember that when you're moving from a denser medium to a less dense medium, something happens. What happens at that point when you're making that movement? What happens? We have to do with refraction, isn't it? That movement, bending away from the normal, when you're moving from one medium to another, brings about refraction. Now, but total internal reflection not happens when there's something called the critical angle. So the angle of incidence is greater than the critical angle. That's what my guy was trying to say. What was his name? Paul. Yes, Paul was trying to mention that the angle of incidence, right? He mentioned angle of incidence will not be greater than the critical angle. That means the minimum angle for that total reflection to occur. Look at what will happen on the norms. If you send in, go and read about these things. Very interesting things. On the norms, when you have your normal, let's say we have a normal this way, these are normal, let me just say this. Then you have something hitting this place. It hits this way. This is your angle of incidence, right? So what happens in refraction? It goes this way, isn't it? It is refracted, isn't it? Angle of incidence and angle of give me a thumbs up if you know what I'm talking about. Good. So now this is the angle between the normal and this is your what? Angle of incidence, isn't it? Then this is your what? The refracted ray. Now it keeps going this way to a point where instead of refracting, we'll now have total internal reflection this way. So this is now where what? Your refracted ray. And at this point, what happens here is that the ray hits a boundary, and just like you guys said, but that was a layman definition of internal reflection. It hits a boundary and then goes back again. But the concept has to do with you linking it to refraction and talking about the increase, the incident angle more than the critical angle. Go and check what your critical angle is, which Paul made a little bit reference to it. I'm not teaching you total internal reflection, but it is something very interesting. Refraction on its own is interesting. In what do you call it? In physics, past question, they start asking you, why is it that the bottom of a pool appears shallow than it actually appears? It's under refraction, isn't it, guys? Why, if you're looking at the pool, it's as if the swimming pool is not deep, that the bottom is just there, right? It's not too deep. Have you seen that kind of question before? Refraction tells you the reason why it is that way. Do I have people in the class? Anybody in the house? Don't give me a thumbs up if you don't know what I'm talking about. Don't just give thumbs up because others are giving thumbs up. Do you know what I'm talking about? Right. So that is some of those things under. Do you know I'm saying all of this? Because I know there's no way I'll cover everything. So I'm saying this so you can go and read, basically. These things are interesting. So they also tell you that you have a biro inside. If you place a pen inside a bowl containing water, the biro appears to be slanted. Try. So now, and it's coming from your what? From your refraction as well. It is also from refraction. They'll tell you why is it so that the biro appears to be slanted, or the pencil to be slanted when you put inside a bowl containing water. Is your refraction. You have the Snell's law. That brings about the Snell's law. Right? Index over reflected. Then you start talking about total internal refraction and all of those things under refraction. You know, after reflection, you now talk about your refraction. And it's under reflection, I think, you start seeing things about that total internal reflection, like these other ones. That's where you get to understand about your eyes, myopia, hypermyopia, right? All of those eye defects, accommodation, you know, and the telescope, how telescope works and the rest of them. These are jump questions. Right? These are jump questions. Where are image formed in front of the retina beam? All of those things are under reflection. Right? I hope I'm going to treat that in the next class. But for today, it's going to be a very brief class. And I want you guys to do better. Nikki, this one you're not giving me a thumbs up again. That means you don't know what I'm talking about, isn't it? But there's one I'll talk about now that nobody will know except both of us. Abi? When it comes to the one that will stay for like 3 hours on your body, you know. That kind of product, isn't it? All right. Don't mind me. And I think you should pay me for promoting your business, Nikki. I'm promoting your business in the class, right? So you have to pay me as your brand ambassador, isn't it? As a brand ambassador. So Nikki, are owing me anyway. All right, so that's for that, guys. So now, please take note that the larger the camera is painted black. Check your past questions. I think I've seen that back in the days, you know. They will tell you, why is the pinhole camera painted? It is because of what? To avoid total internal reflection. And then the hole, as you make the hole larger, the image becomes brighter. And the brighter the image, it becomes blurry, right? So that's one key disadvantage of increasing the hole of the camera. It becomes brighter, but then it's going to be what? It's going to be what? Blur. Please take note of these key concepts. Right now, that now brings about what we call magnification. There is something I had when I bought one small Bible. The first Bible I bought for myself, I bought that Bible in 2017, right? So there is this thing inside of it that when you bring it closer to the Bible, it zooms the letters. because the Bible was quite tiny, very small. So they now made provision for the magnifying glass. I don't know how I lost that glass. I was so pained, right? Maybe someone picked it in church and kept it well for me. I think so. I believe the person didn't actually take it. The person just
Okay,
kept it well in the house.
that's glass that
In the
comes
house.
with pen.
I didn't hear you.
There's this pen we normally buy when we're in school. It has glass that enlarges the size of
Good. So my own was more like a paper this way, like a paper like this, very something very light, right? Very light. That when you bring it closer, it zooms the image, the letters. So now that magnification now, that's the formula. The height of the image over the height of the object is equal to the distance of the image over the distance of the object, right? So now that's your formula. Do you have questions under this? I don't know if Paul have seen any, right? So you have hi over ho is equal to v over u. That's the magnification formula, where v is the image, distance of the image distance, and u is the object distance, right? So that gives you the magnification of the object, how you can magnify the object. But there's something key I wrote here. If v increases, the image size is going to increase. What is v? V is the what? The image distance, right? And why will it increase? You can see that they are directly proportional. M and V are directly proportional. The higher the V, the more the magnification. But as this one increases, your M decreases because they are inversely proportional. Anytime you have something like this, in case you don't know, if you have a formula that says, let me use density as an example. Density is equal to M over V, mass over volume. So now, if mass increases, density increases as well because they are directly proportional. The one up. Now, if this down one, which is your volume, right? If volume decreases, this one increases. But if volume increases, this one decreases because they are inversely proportional. Do you get what I'm trying to say, guys? Do you understand what I'm trying to say? If you don't understand, you say you don't understand. If you understand, you tell me you understand. Eh? I'm not a newscaster. I'm teaching. Good. Justice, do you get the point? You guys want me to be calling your names. I know you guys enjoy me calling your names. Justice, do you understand what I said? Titi, do you understand what I'm saying? You guys will miss my voice very soon. Don't worry, you guys will miss it. Just from after, very soon you guys will miss my voice. Maybe? Don't worry. All right. So what I said there is that if, first of all, do we know what it means for something to be directly proportional? You know, sometimes we don't know something. We use guy way, guy man way. You don't understand. But do you know what is direct proportional? So now, if something is directly proportional, it means that as A increases, B increases as well. For example, now, stress is directly proportional to weight loss. The more you stress yourself, the more weight you lose. Do you understand it now? Because this one increases, this one increases. If you reduce your stress level, at least you should gain a little weight. I'm using myself as an example because these days I can't wear anything shorthand and go outside. Anything shorthand, I can't wear it and go because, man, well, let's not go there. So I prefer wearing long hand now so that people will not know what the young man is going through. Like I've lost a lot of weight, basically. Except the weight on my nose. That one keeps increasing. I don't know why. So basically, always pay attention to direct proportional. This one increases, the other one increases as well. The other one decreases, the other one decreases. While you are laughing, I hope you understand what direct proportional means. Inversely means as this one increases, the other one decreases. As the other one decreases, the other one increases. Is that okay now, Justice? So which means that, and M is directly proportional to V. So which means if the image distance increases, the image height size is going to increase. If the image distance decreases, this one will decrease. But because these two are inversely proportional, so if this one increases, this guy will decrease. You get, so that's what that statement is trying to tell you. JAMB will ask you, the image size will have increased by 3. What happens to the image distance increased by 3? What happens to the image size? Have you seen that kind of question? They like asking it. Will it double? Will it triple? The concept is coming from here. Yeah, Paul, check for those things now. What happens to the image size when this one is tripled? What happens? Is under directly proportionality. They want to know if you understand the concept on how you can relate them based on their their relationship, right? So automatically it means that if I double the image distance, that's V, automatically I will double the image size because they are directly proportional. If I double if I double this one, U, the object distance, if I double the object distance, what happens? Once I double the object distance, what happens to the image size? The image size will reduce by half because the relationship will increase, decrease. Everybody, are we on the same page now? Are we all on the same page now? Susan, are you here? Titi, are you following?
Yes, sir.
Susan, are you confused?
Yes.
Okay, find yourself. Is that okay?
Yes, sir.
Okay. Also, about fine, sir. This young lady, very funny. So now, directly proportional and then inverse proportional. Just you can play the recording again, or someone can explain to you. Sismo girls, when you guys go to the group, explain to her. Use things that she can understand. You know, all those in a discussion. Use it for her so that in a discussion. You know how women discussion can be. So use anything along that example, so that Susan can grab it. Okay, Susan, is that okay by you? They can explain to you, right?
Yes, sir.
All right, great. So let's continue. So now let's look at eclipse now. Eclipse is another factor, right, that tells us what happens regarding the rectilinear propagation of light, right? So now, I didn't hear you. The last eclipse I witnessed, I was in primary 2 or thereabouts. So many years ago, but I didn't see anything. That woman said, oh, "We're going to the class, going to the," but now wait, now we see what's happen now. You get, so that was the last time we heard about that. There's eclipse and the rest. But I can remember everywhere became so dark. They were chasing us inside the class and blah blah blah. But in other schools, in the advanced world, they will find a way so that students will witness what is happening. Uruto and I, they say go inside. I won't go inside class. Eh? So I can remember I was very small that time. Everybody was so afraid, I can remember the fear going as if the thing will come carry you or something. Because when I grew up, I said, if I find that woman that did that, because the narration they were actually giving as if something bad was about to happen. If you come outside, maybe something will carry you or something. I don't even know, all of those things. You get. I'm telling you, that was the feeling I had back then. Maybe if you come outside, the thing will be like breeze. They come, may carry you. But it was an interesting thing happening at that point in time, where exactly I would like to. I think I was in primary 2, but we couldn't see what was happening. Some people say that if you pour water inside bucket and look at it, that you are going to. I can't. It's been very long. You can remember primary 2. Primary 2. The only thing I knew back then is that there was fear around everything. People were running around, helter skelter, our teacher running up and down. Even I believe that the woman don't even know what eclipse is all about, and I know it totally. She might not have known, basically. But at least she taught me how to read and write, and that was the most important thing. Eclipse or eclipse, no say that one concern. All right, so we have the eclipse of the sun and the eclipse of the moon. So it's important to know that sun is luminous, which means it produces its own light. But moon and the earth, they don't produce any light. So the light they radiate is a light that has come from the sun, right? So an object that can produce the sun on its own is said to be what? Luminous, isn't it? Right there. Now, what is now the eclipse of the moon? Let's start from there. Now, how it happens? Because the moon is opaque, right? It doesn't allow light to pass through it. If you now line up the sun, the moon, and the earth, because like they've taught us already, all of us know that the moon actually takes the light from the sun and then reflects it back to us during the night. So we have the full moon, the half moon, right? And I would say that when there is moon, it's quite interesting. Like there's this calmness, there's this serenity, that it gives. And that's when you get to appreciate the handwork of God. As somebody will become, you'll be seeing the person's face at some point when there is moon, isn't it? Right? Especially when there's this full moon, exactly. So it's quite interesting, basically. For people that come outside, some of you, once it's 5:30, they lock you inside the house. Like people like us that go outside, to see what happens at night, basically. Right. All right. So what happens in the eclipse of the moon? Now, we know that the moon circles the earth, right? let's say when the sun, the earth, and the moon are in line, right? And the earth being opaque, an opaque object will cast a shadow on the moon, right? Let me see. Let me see whether I drew an image. Good. So this is the sun, and then the earth is now in between the sun and the moon, preventing the moon from receiving its light. Are you seeing that now? So when that happens, the earth is going to cast a shadow. Oh, Justice, you're not following.
I've
Should I
not
go
seen the
back?
image.
Eh?
I've not seen the image.
Oh, you've not seen the image. No, look at what I'm talking about. This circle I drew here, not a very special image, actually. Can you see that circle? That's a circle, not a particular image. Forgive me, sir. Forgive me. Actually, on a, if not for time, right? And that's why I wanted to get someone else to take these classes. You get, but because of a lot of situations that we can't carry the responsibilities, I had to do that. Because all of these things, as if you check, this was it was unwritten. I couldn't even use my tab to write, so it's very nice. Include images, right? But on your own, that's why you are a student, and that's why I have a smartphone. So just please Google the image eclipse of the moon, so you can see every other detail, right? Because of time, I would have done that for you as always, arrange it and make it very nice. But then, at this point, is to cover and not to make it more beautiful at this point. So, but this my diagram is very powerful, right? There's no way, there's no place you can't see this diagram anywhere. There's no place you're going to see this my eclipse of the moon and so on. So now this is the sun right here, right? This is the sun. This is the and this is the moon. So what are we trying to say? That at that point when you have the earth in between the moon and the sun, because the earth is opaque, right? Mess, you don't laugh tired today. So now it prevents the moon from receiving its sun. Just like an obstacle, it blocks it as it's coming, it's blocking it. So therefore, the earth, the moon will not receive any light, right? So now that is what the eclipse of the moon is all about. And I gave a description. So I said, when the sun, the earth, and the moon are in line, the earth being an opaque object casts shadow on the moon, right? So since the moon is now receiving what? No light from the sun, it has none to reflect back, and thus it cannot be seen. There is nothing to reflect back, and it cannot be seen. We say that there is an eclipse of the moon. Are you seeing that? So it's simply when the earth is in between the sun and the moon. We say there's eclipse of the moon. Is that okay? Now, but there are key things you need to know. We also have the penumbra and umbra, right? That part of the kind of that eclipse as well. They are, in as much as the earth is casting a shadow on the moon, there are some portion that light can reach, which is your penumbra, and there are some part that light cannot reach, which is your what? Your umbra. Take note of that when they start asking you along the sun, the earth, and the moon. Then the next one is the eclipse of the sun, right? So eclipse of the sun, that's the one that when it happens, that's the one that they said that happened that time. I think can I remember the year? Should I be in primary 2 in 2006? I can't remember. I know in 29 I was in primary 6, 29. So 27, 28, 29, maybe around 2004 thereabout. If I was in my 6 in 2009, so 6 minus 4 should be 2, right? So 9 minus 4 should be around 5, 2005, right? So let me Google something. Let me Google the last eclipse of the sun. Let's be correct.
So I have a question.
Yeah, I'm coming. That is March. I'm very current too. I can prove that. It was March 2026, right? Was it March? The March. Okay, the last solar eclipse visible in Nigeria was a partial solar eclipse on September 1, 2016, which was observed in Lagos, Abuja, and Benin, and a more significant total eclipse widely viewed across many northern and eastern states occurred early in March 29th, 2006. Yeah, I think that of 2006 was the one they were talking about back then. Yes. Yeah, ask your question now.
I've understood it based on
Justice.
what you said. I wanted to ask if that eclipse, if it happened, will it happen throughout the world, all over the
Okay,
world?
no, it's on. Yeah, no, not all over. You know how that rotation will be now. The Earth, you have the sun, you have the moon, you have the Earth. So the moon, there are some portion. That's what I spoke about. That partial eclipse, like that penumbra and umbra. The whole thing based on rotation now. So the moon, there are some portion that will be covered, portion of the Earth that will be covered by the moon. Not all of them. You get the point. That's what. To be sincere, when I was in primary school, what I wanted to study is astronomy. I so much loved things about the planet and the rest of them. You get, I so much loved it. But they told me there's no way to study. I was even in just one where they started saying that there's no place you're going to study it in Nigeria. And is that not true? Is it true? Is there any school that offers that as a course? Any school? What's the name of the school? So I will go back. What's the name of the school? Someone should mention the name of the school. So I will go back. Sincerely, I so much loved it. And back then, as a child, during that NTA news where they do the weather forecast, if you watch weather forecast, that was my favorite. I don't play with it. I don't play with that weather forecast. Okay, so and so time, the temperature today will be 29 degrees Celsius, 30 degrees. The thing will just fit me. Right, but this is me. Astronomy, I don't do. Engineering, what I do, I don't live out. All right, so that's entirely fine anyway. You got that when university. Now you got to attend that they will give you that school you mentioned, they will give you admission on merit. Your name will be number one on the merit list. All right, so let's look at the eclipse of the sun now, guys. So when the moon comes between the sun and the earth, the shadow of the moon may fall on the earth, right? So look at it now. Justice, this answers your question now. If we are living in the part of the earth that is in the moon's shadow, are you seeing it now? Even that one that happened in March, it didn't. They said in Enugu, it didn't happen in Enugu, and that woman was running around that, and they were running around that period. It just happened in some places. I think Lagos, I think Benin and some part of Nigeria witnessed it. It happened in Lagos precisely. So us in Enugu, we didn't see anything. But you see the kind of fear that period there, right? So they said if we're living in a part of the earth that is in moon shadow, the light from the sun is cut out, and we are in what? We are in darkness. Have you seen how it works now? So that portion, right? Those portion of it will not be in darkness, right? So now, what I wanted to write here is that if we cannot see the sun, we call it what? The eclipse of what? Eclipse of the sun. Is that okay? Right. Now, for those, are you paying attention now? For those in the penumbra, it is now partial eclipse. Are you seeing it now? For those in the penumbra, okay, I think I wrote it here. For it is total eclipse for people in the umbra area of the shadow. Total eclipse for them. And that was what happened in March 2006, right? There was a total eclipse. But I think that of 2016 September was a partial eclipse. That means we are at the penumbra. Are you seeing it now? So for those at the umbra, which means at that point where the moon is covering, experience total eclipse. Then for those in the penumbra area of the shadow, let me complete it now. Of the shadow. For those in area of the shadow experiences a partial eclipse. A partial eclipse. Is that okay, guys? Good. All right. All right. So you can also look at the annual. I have an assignment for you now. You're going to check out for the annular eclipse, okay? Yeah, annular eclipse of the sun, right? The concept behind the annular eclipse of the sun. So these are the key things under your light, right? The rectilinear propagation of light. Like I said, it's going to be a very brief class today. That's your rectilinear propagation of light. Are we together, guys? All right. So, Paul, did you see any question on that? Or any?
I'll send them to you soonest.
Soonest. You people just like English. What I told you to do to actually send to me since now you can't say soonest. Huh? Sure. All right. So now that said, the next portion of our lesson will be on the reflection of light from plane surfaces. Reflection of light from what? Plane surfaces. That will be the next. So let me just create a new page. Reflection of light from plane surfaces. So the next is going to be on the reflection of light, right? Reflection of light from plane surfaces. Yeah, it's going to be a very quick one. So we're going to look at the laws of reflection, right? Look at those glass prism and the rest of them. What happens to that particular point? I think we went at the only part that might be a little bit dicey is the sound wave, right? The sound wave, sometimes you start hearing about pipe, first harmonics, second harmonics, third harmonics. Yeah, Justice, go ahead. Your hands are up.
So is it under that reflection as they talked about mirage, that total reflection?
Mirage should be under refraction.
Okay.
Mirage is under refraction, right? So because under this reflection is the places they spoke about, all those your telescope and the rest of them. Yeah, mirage, that one has to do with top of the surface now. What you are seeing is the top of the tree, isn't it? Yeah, I think it should be under refraction actually. So after that, we'll have reflection by curved mirrors, right? After reflection from plane surfaces, we'll have reflection from curved mirrors. Reflection from curved mirrors. Right, we'll have curved mirrors. After that, I think we'll have for lenses as well, right? You start looking at focal length. I'll be glad to look at those places. Image height, 1 over focal length, that formula, 1 over V. Jam, there's no year you cannot see this. There's no year you can see it. Any day, the only year you don't see it, that's not, you're not writing physics, right? So you're going to see things along reflection of light from plane surfaces. You're going to see reflection of from curved mirrors because they want to see whether you understand your concave mirror, your convex mirror, what are the properties and the rest of them, the principal focus, right? So I think in the next class, I should be able to handle this guy and this guy at the same time, most probably, right? After which we'll now look at the refraction at plane surfaces. So under that refraction now is where you're going to see that total internal reflection that I asked you earlier, and you're going to see total, that's the deviation, right? Critical angle, total internal reflection. Yeah, that mirage is there, bro. I was correct. Reflection is under that place. Under your refraction is your mirage, right? Before you start seeing electricity and the rest. Paul, any show? Or should I move from here?
So
Yeah,
they will
Justice,
land
your
in-
hands are up. I didn't hear you.
they will
He's
land in
landing.
few seconds.
Okay. You know I'm in Enugu. Maybe I should go to the airport, Nanda Zikiwe, and receive it. Yeah, Justice, your hands were up before now. Okay, all is well. So please check this thing before coming to the next class. You can use today and do that. Just one night. Reflection of light from plane surfaces. Go on YouTube, right? Go on YouTube. Look at that reflection of light from plane surfaces. Look at reflection from curved mirror. Look at refraction. Like these things, you can cover them. I'm serious about this. But then I'm going to see us tomorrow. Is what? It's Thursday, isn't it? Tomorrow is Thursday, isn't it? Yeah. So, but I think Mr. Kunle said he will not be available on Friday, right? So that Friday morning, there's going to be class. So that Friday, I'm going to use that to teach you reflection of light from plane surfaces, and then I will touch reflection from curved mirrors on Friday. So having a class on Friday, it might be up to 3 hours class that Friday. From that morning, from 10 a.m., we might have up to like 3 hours class, as the case might be, right? So it's to cover reflection of light from plane surfaces and reflection from curved mirrors. What's the problem? Some persons are giving me that crying emoji. What happened? You'll not be around?
3 hours.
No, if I stay in class with you 4 hours, do you feel it? You'll not feel it. 3 of us. Be sincere.
Sir,
If I'm teaching for, if I'm teaching,
more lively than
uh,
all the teaching stuff.
if I stay 4 hours in class, you will not know. Am I lying? If we stay 4 hours together, you will not know.
You
I will
don't
be
know.
laughing and I will not know. It's just that it will not be convenient for me.
So I've
So
sent
there's
it.
no. Okay, I've seen it. Thank you, Paul. Okay. 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 This is divergent lens. They might not be able to do this one. Concave lens. Good. All right. They said the image. Are you listening now? When you enter university, you take. Meso, what did you say?
That you enter uni, you should be asking his lecturer 4 hours. If you enter uni, you can 5 hours.
Yes, nah. Sorry, expect it, my dear. Even the ones you have to expect it. Rachel, sorry about that. The class will be recorded. It will be recorded, right? And as you're even listening to the recording, you're enjoying it. I know watching recordings can be difficult sometimes, though. But that's why in between I like putting all those plays so that as you're watching, you are laughing and you're also learning while watching the recording, so that you feel the moment. And then so it can also pain you. You'll be like, I wish I did class when they crack this joke. I mean, not be so. Because the live session, you not the same. All right, the image in the pinhole camera. This is question number 1, from what our brother sent. Image in a pinhole camera is one. They said inverted and formed by the light from each point traveling in a straight line. I go again. The image in a pinhole camera is one, inverted and formed by the light from each point traveling in a straight line. B, erect and formed by refraction through a lens. C, virtual and formed by dispersion. D, erect and gets sharper as the hole becomes larger. So which one? A, right? Good. Because it is inverted, good, and formed by the lights from each point traveling in a straight line. Because that's a pinhole camera is trying to teach us that it's a linear propagation of light. D would have been correct if they said inverted and gets sharper as the hole becomes larger, isn't it? Right? It gets brighter as the hole becomes larger. Yeah. So which other one? I think more. Paul, you sent more of refractive index and the rest. Kaleidoscope, right? That will be in our next class. All of these ones we tackled, right? Object, light, frequency. Okay, let me ask us these questions and then let's see people that have been following, right? Let's see. Okay. What is the effect of the image produced? Are you listening now? What is the effect of the image produced by the pinhole camera? What is the effect of the image produced by the pinhole camera, right, when the object distance is doubled? What is the effect on the image produced when the object distance is doubled? When the object distance is produced. When the object distance is doubled. Anybody saying anything? I go again. Eh? Image size is increased by half. Titi.
It is decreased by half.
By half. Titi, what's happening? Titi, are you there? It's gonna decrease by half, right? Unless you wanted to write decrease, it's gonna decrease by half. All right, so look at this question now. In a pinhole camera, they will round it up with this. Please don't miss that Friday class. All right, it's gonna be as amazing as the one on Wave. In a pinhole camera, the distance between the pinhole. I wanted to write decrease. My Gemini typed rubbish. Okay. Sorry about that. Was the answer coming from your Gemini? I don't understand. Or you are using Gemini keyboard? Is it Gemini or Gemini? How do you guys pronounce it? Okay. All right. So it said, what is the height of the object? 100 users. Okay. You got okay. Let me not talk too much. 100 users. Okay, you're an iPhone user now. Oh, voila. What is the height? Titi, hide yourself now. You don't even say Samsung for the Android. What's your problem? You're measuring Redmi. What is the height of an object? What is the height of? Okay, they said in a pinhole camera, the distance between the pinhole and beside the pinhole and the screen is 25. So what is the height of an object placed? Height of an object placed 100 centimeter, from the pinhole. From the pinhole, right? Are you seeing it now? When the image in the camera is 10 centimeter. Are you there now? In the centimeter, then the question now goes ahead to say, what is, I want you guys to solve this question. Try it. What is the magnification produced? Question mark. If the distance between the object and the pinhole is halved. All right, so what is the height of the image? All right, such a long question, but then captures everything I need you to understand. So you can now go ahead and answer your past question. It captures everything I want you to understand. So anybody that wants to try, do you have any brother or any sister in the house that wants to handle this? Brother, sisters, anybody? Or should I go ahead? Okay, Justice, you want to try. So remember, let me just highlight key points for you guys. Right, so let's highlight key points. Meanwhile, how come I'm writing this way? What happens to this space here? Oh, wow. This one got a homish touch. So now you have a pinhole camera. The distance between the pinhole and the screen, right? Between the pinhole and the screen is 25 centimeter. Are you seeing it now? So the distance between your pinhole and the screen is 25 centimeter. So check what they've given you at that point in time, right? So they've given you the image distance. So this 25 is the image distance. Now, what is the height of an object placed 100 centimeter from the pinhole? So now they've given you 100. 100 is your what? Is your U. That's your object distance. 25 is the image distance. So I'm just giving you the parameters so that you can be solving it now, right? So they've given us here the parameters. This is your V, all right? This is your U, are you there? From the pinhole, when the image in the camera is 10 centimeter. So now, sorry, here is U. So this is image height. This is the image height. Now remember the formula you're going to use. What's the formula? Can we remember? So solution, let me just be writing for you guys, right? So we're going to have the height. Okay, thank you, Justice. So remember the formula, that image height. Thank you, Justice. Image height all over the object height is equal to the image distance. Let's use image D over what? Over object distance. So the image height was given to us. So they say, what's the height of the object? So image height magnification 0.25 makes sense. Yeah, is someone working alongside with Justice? So image in the camera, they give us 10 right here. So here is 10. This is 10 over the object height, right? Is equal to the image distance. Anyone getting the same answer as Justice? The image distance is 25. Object distance. Yeah, Titi, I didn't hear. What did you say, Titi? This is 25 over U. Did you give a thumbs up? 25 over. Okay, people are getting the same answer as him. Okay, that makes sense. So this is 10 times 100. Lillian, I think you're just joining, isn't it? 10 times 100 is equal to 25. Let's call it H of image. So now, Justice, what was your image height?
40.
40, right? So this is 1000 divided by, good. So this is equal to 1000 all over 25, which is equal to 40 centimeter. Now the question now goes ahead to ask us, what is the magnification? What is the magnification produced, right? When the image camera, what's my, okay, you said the magnification is simply the object. You can use anyone. You can use image height over object height, or the image distance over object distance. It should give you the same thing. So if you use anyone, 12 over 100 is what? 4 into 5, yeah, 1 over 4, right? And 1 over 4 is what?
0.25 is what I
0.25. Okay. Makes sense. The next one, if the distance between the object and the pinhole is halved, what is the height of the image? If the distance between the object and the pinhole is halved, what is the height of the image? The same process, right? Remember that if you have the distance between the, just sort of, let me see what you guys are going to do. Nobody have produced the answer for that one. Right? You said?
I said since it's half, that 4 to become 20 divided by 2.
Good. Good. So image height is 20, right? Do you understand why it got 20? You can simply use your magnification formula as well, right? You can use your M. Remember that M is equal to V over U. Then they said that if the distance between the object and the pinhole is halved, right? So now you are halving your U. And what's the value of our object height?
What?
No. So what's the height of the object? 30 centimeter from the pinhole. So 100 by this is, you can use 25 over 50 actually. That was to give us, then you have your magnification formula, right? Let me check again. What other approach can we use? If distance between the objects is halved, right? The distance, what was our distance for the object? 40, right? So if you have, yeah, just like what this guy said, when you have it, it's still going to give us 20 right there, right? Anybody confused? Any confused person or missed? So that's the process. Just go check your past questions under these things. And I'm going to see you guys on Friday, where I'm going to look at reflection. Lillian, you joined very late. Once the recording is, I think the recording is going to be faster this time because we didn't spend close to 2 hours. I think the class is about 1 hour, 1 hour, 30 minutes, I mean. So it's going to be very fast. So when it comes up, I'm going to send it to you so you can send to your dashboard rather, so you can watch. All right. So all the best, guys. Please keep studying. What do you guys have this afternoon by 12:30? What do you have by 12:30? Is it chemistry or biology?
Biology.
Biology. Okay, interesting. So all the best, guys. Please. This is our week 7, isn't it? And there are videos on your dashboard for week 7. I don't know what you guys are doing, but then I will still cover your reflection, and I'm still going to cover curved surfaces, and let's see how far we could go from Friday. Right. So all the best, guys. All the best, Justice. All the best, Titi, Lola, Suzanne, Lillian, Confidence. Who again? Gifts. Nikki Goat Silva, and the rest of you. Right. Please keep checking on others too to know how they are doing. Right. Peace out, guys. Oh, Confidence gave me love emoji. Ah, sure. All right now. Thanks, Lillian. Thank you, everyone. Yeah, Titi no go give me love emoji. No wala. Don't worry. Titi na clap, you dey clap for me, Jare. No wala. All the best. All right, guys. I will send the material to the group as well. All right.
Guys, in the group, people have discussion group. I don't know.
They don't have. If you don't want to create for yourselves now, people don't have.